Hello. Can you hear me? Hello, Dom and Paula. Just want to make sure you can hear me. Hello. Can you hear me? Great. Okay, so Dom, you're the and Paula. First one. Just want to make sure you can hear me. And hold on, I have to figure out why I can hear myself. So I'm going to get off. Great. Okay, so Dom, you're the and Paula. First one. Just want to make sure you can hear me. And hold on, I have to figure out why I can hear myself. So I'm going to get off. Great. Okay, so Dom, you're the first one. Just want to make sure you can hear me. And hold on, I have to figure out why I can hear myself. So I've got it on two different places. Hold on one second. I've got it on two different places. Hold on one second. I've got it on two different places. Hold on one second. Okay, well, I still haven't quite figured this out. Do you guys hear my feedback, or is everything clear to you? Because I'm hearing myself talk and then hearing it played back to me. And if you're not hearing that, then I can just deal with it. But okay, well, I still haven't quite figured this out. Do you guys hear my feedback, or is everything clear to you? Because I'm hearing myself talk and then hearing it played back to me. And if you're not hearing that, then I can just deal with it. But okay, well, I still haven't quite figured this out. Okay, yeah, I don't. How about now? There's going to be a little delay. Can you hear me now? Can you hear me now? Do you hear any feedback now? Because I don't hear anything, but I don't know if you can hear me at all. Okay, that's good. So it's complicated, but I think we're ready to go now. So I'm going to start with you, Dom, and answer your question first. And Paula, you can just hang out. And so the first thing that you wanted to do, Dom, was number 6, the 4.2 marginal analysis homework. Now, do you mean the lab manual or WebAssign? Okay, so while you figure that out, Dom, you've got to tell me
Wait a minute. There's a delay. So I got to make sure. Can you guys hear me okay? Okay, you can hear me. Okay. All right, so WebAssign 4.2, number 6. All right, well, I'm going to go over there now. And share the screen. And okay. Open up Excel. And I guess I'll go to Firefox. And hopefully you can see the screen. There's a little bit of delay. I don't really need Firefox to do my updates. Okay, so it's working. I'm still waiting on Firefox. Good grief. And I can't see what WebAssign number 6 is until I can get another browser open, but things are really starting to be slow here. And my computer. All right, I'm going to leave it alone, and I'm going to go back to Google Hangouts and stop sharing the screen for a little while. And answer Paula's question, because I'm still waiting on something to open up, Dom, so can't really do anything until I get there. So let's look at page 19. And number 13. Okay. So so page 19, number 13. Dom, this is Math 172. It's not you. You have to figure out what this trig identity is. And so you have to figure out what this is. It looks like a sum or difference formula. So I'm going to turn over to page 15. And I'm going to look for it. And it's got 2 sines and then a minus and 2 cosines. So that's going to be okay, so that's why this one's tricky. Okay, so look right here. I'm going to underline that. This says cosine A, cosine B minus sine A, sine B. So the cosines are positive and the sines are negative. Let me write that down so we don't have to keep looking. So this trig identity is what we're going to use. Okay, so what we see is that this is not quite right. This has got sine first and cosine second. So what we can do is we can actually factor out a -1. So if we factor out a -1, then what that's going to do is make that negative. And that positive. And so now it is the right setup if we rewrite it this way. Okay, so now what we have is this trig identity, cosine A, cosine B. So this is A and this is B. and this is A, and this is B. Cosine A, cosine B minus sine A, sine B equals cosine A plus B. So this equals -1 cosine A plus B, which is 3x plus 2x, which is -1 cosine 5x. So that is, let me go back to page 19. That is found right here at H. Okay, so there's a huge delay, and I am still waiting on Firefox, and oh, it's now open, so great. So Dom, yep, you're welcome. I'm going to go back and screen share now, and I can open up WebAssign in Firefox. So just didn't want to open up. There we go. Okay, so let me go to Blackboard. It's going to be a little bit better if I've got the lab manual problems, a little bit better if we work on those lab manual problems, but I can do this once it's just very slow. The computer's really, really slow, so I still am having bad luck getting it to open. Just doesn't want to do it. Let's try it this way. I didn't anticipate this. It's just not wanting to open. Let's see if I can try again. Let's see. Get into WebAssign this way. All right, let me leave Firefox. It's not behaving. Okay, I'm getting it opened. We're going to go to our class. And marginal analysis. Almost there. Number 6. Okay, so I'm going to snip this. Maybe. There we go. And go to Excel. Okay, so this problem says, assume the demand function for tuna in a small coastal town is given by P equals 20,000 over Q to the 1.5, where P is the price in dollars per pound of tuna. Q is the number of pounds of tuna that can be sold at the price P per month, or in a month. We want to calculate the price that the town's fishery should charge for tuna in order to produce a demand of 400 pounds of tuna per month. So we have a price equation that says if I know the number of tuna, I'll know the price. Well, this question is asking the price if they should charge in order to produce a demand of 400 pounds. So what that means is you want to find out what P is when you have 400 pounds. Okay, so I'm doing some work on my paper, and I'll show that in a second. But So that one, all you do is basically you are going to plug 400 in for Q. Okay, so that's pretty easy. All right, then you have to calculate the monthly revenue. And so revenue is independent variable Q. R of Q is P times Q. So I'll show my work there. And then it says calculate the revenue and the marginal revenue. So next, that would be you want to take the derivative of revenue and you want to evaluate at 400. So I'm just trying to write all this down. And then you want to interpret the results. Okay, so I'm going to go back to the screen and okay, so I'm going to go ahead and build this function. I need to put this in to Excel, so I'm going to do that. That was the demand. Price equals 20,000 divided by Q to the 1.5 is the same thing as 20,000 times Q to the negative 1.5. Okay, and then it says to find the price when you have 400, so you put 400 in for Q. So I'm going to let Excel do that. Then it says build a revenue function. Q is my input, so that's how I knew it's going to be an R of Q function, and I know that revenue is price times quantity, so I need to get rid of price by plugging that demand equation in. So that's R of Q equals 20,000 Q to the negative 1.5 times Q to the 1. So I can simplify that. That's R of Q equals 20,000. And then the way you add powers together is you add the exponent. So that's negative 1.5 plus 1. So that's Q to the negative 0.5. So that's my revenue function. I'll put that in Excel. Then it says find the marginal revenue. The marginal revenue, that's the first derivative. So this derivative would be 20,000 times a negative 0.5, which is just negative 10,000 Q to the negative 1.5 because you have to subtract 1. And then it says find the marginal revenue at 400, and then it says to interpret. Okay, so I'm going to type all of that in to Excel. So I'm going to go back and start sharing the screen and get to my Excel. Okay, there we go. So when I do this, I know I'm going to have P, and Q is my demand function, so I'm going to put that in, and that's 20,000 times Q to the negative 1.5. I want to evaluate that. I'm sorry, I put that in the wrong. This is Q. That's my input, and that's P. And I want to evaluate that when the quantity is 400. Okay, so that's P. So this is 400 pounds of tuna, and the price would be $2.50 because price is in dollars. So that's why that answer is there. Okay, then it says calculate the monthly revenue, and that's what I got, 20,000 Q to the negative 0.5. Then it says calculate the revenue and the marginal revenue at a demand level of 400 pounds. So now I'm going to put in the revenue, which is an R of Q, and I don't really need to type that function in because I know revenue is price times quantity. So I can just type in, click the P column times the Q column. But Excel doesn't take derivatives, of course. So you have to take the derivative, and we did, and you have to type that in. There is no shortcut. So we found the derivative to be negative 10,000 times Q to the negative 1.5 and evaluating it at a level of 400. So now you would put 1,000 in the blank. The revenue is $1,000 at 400 pounds of tuna, and the marginal revenue is negative. Looks like I must have a typo here. So let me see what I type in. Okay, it's off by decimal. Okay, it's not. There it is. It's, yeah, I sure did. I lost a 0. There we go. Okay, and so the marginal revenue is negative 1.25 in this blank. Now to interpret the results, remember the The marginal revenue should be interpreted differently. Whenever it says marginal, we really, the 401st pound of tuna costs approximately $1.25 per pound. So I just realizing that this is a little bit wrong the way WebAssign's done it, but that's okay because you asked about it. That's what I'd want on the test, but WebAssign is interpreting it as an IRC. At a demand level of 400 pounds per month, the revenue is $1,000, and it is decreasing at a rate of $1.25 per additional pound of tuna. And then it says if the town fisheries monthly tuna catch amounted to 400 pounds of tuna and the price is at the level in Part A, would you recommend the fishery raise or lower the price to increase its revenue? Okay, that's a little bit wordy. Let's see, the level at Part A. Would you recommend that they raise or lower the price? Okay, so what's going on is at this 400 pounds of tuna, the price is at $2.50. And at this 400 pounds, the revenue is decreasing. So that's not good. You don't want revenue to decrease. So just from kind of thinking through that, that's why you would raise the price. Okay, so I'm going to stop sharing for just a second. Uh-oh. I hope you could see that. Oh, this is crazy. Okay. Okay, so I'm not sure what you saw. Oh yeah, it didn't share the screen. Okay. So I'll go back. I'll share it. I have to go back to two different screens, so this is kind of strange. All right. Let me try one more time to screen share and I'll show you. Share. Okay. Let me ask you. All right. Okay. Can you see it now? Okay, sorry about that. All right, and somebody else load up a different question, so I'm ready to go because I'm almost done with this one. Okay, Dom, so let me try this again. All right, so Q, see right here, Q is your independent variable. So that starts there, okay? And we want to evaluate the price for A when it's 400 pounds. So I put 400 in there, and the P is this equation right here, 20,000 times Q to the negative 1.5. So that's what I put in there, 20,000 times Q to the negative 1.5. And then the revenue function, again, the revenue function is just price times quantity. So there's no need to type that in. I just clicked on P times Q. But the derivative I have to type in. So I typed in negative 1,000 times Q to the negative 1.5. So hopefully you saw when I did the work on paper. Okay, now the calculate the price at 400, that's 250 right there. So when you put 400 in for quantity, which is pounds, you get a price of 250. So that goes there. And then the monthly revenue function, I showed my work there. and then calculate the revenue and marginal revenue. Well, at 400, the revenue was 1,000, so that would go in that blank. And the marginal revenue is negative 1.25, so that would go here. And then what I was saying is on the video about marginal analysis, if you watch that, I say that when we want to interpret marginal revenue, we want to remember that it's if what you put in there is 400, then the marginal revenue is the 401st pound of tuna, because that's what Q is, costs. Or oops, I shouldn't say cost. I do that a lot. Yields a revenue of approximately $1.25 per pound. But WebAssign wants you kind of to interpret it as an IRC. It says at a demand level of 400 pounds per month, the revenue is $1,000, and since it's negative, it's decreasing at a rate of, and you would put 1.25 per additional pound of tuna. Now, what I was saying here, this last question, if it costs them, if it's giving them a revenue of $250, or the price is $250 when they make 400 pounds of tuna, and the revenue is decreasing, we don't want revenue to decrease, so they should raise the price. So that's what's going on there. Okay. All right, I'm going to stop sharing now and go back to some Math 172. Okay, and I gotta see what the question was, because all right, so number 1 on page 18. Yeah, once you see how to start this problem, and Paula, I posted a handwritten key to try to help with that. It's in the sum difference formula lesson. Great, I'm so glad, Dom. It's such crazy right now. But so let me do that Math 171 problem. All right, page 18, number 1, and it says, given that tangent of alpha is 8/15 and secant of beta is negative 13/5, and then it says that alpha is between 180 and 270, which means it is in quadrant 3, and beta is between 90 and 180. Well, that means that it is in quadrant 2. Okay, so usually when you guys get stuck, you have to draw a right triangle. Okay, because this is an angle, and so it's in, this alpha is in quadrant 3. So I'm going to draw my right triangle so that the angle's in quadrant 3. So there's my terminal side, and this angle, reference angle, is in quadrant 3. And tangent, oh, excuse me, that shouldn't be theta, it's alpha. So you would draw this alpha out, and that's 8 over opposite over adjacent. And since it's in quadrant 3, they're both negative. And so then you would find this hypotenuse by doing the Pythagorean theorem. So that's going to be 64 plus 225. And the square root of 289 is 17. Okay, so I've drawn out my tangent. Alpha equals 8/15, and I have that. And then I have to draw this one. And this beta is in quadrant 2. So I'm going to draw my terminal side in quadrant 2, draw a right triangle down to the x-axis, and this is beta. This is where beta is, this angle. And it's secant, and secant is the reciprocal of cosine. So secant is hypotenuse over adjacent. That's what secant is. So the hypotenuse is here, and the adjacent is here, and I'm going to give the 5 the negative because the hypotenuse is never negative. And then I'm going to use the Pythagorean theorem to find that side. So that would be 13 squared, which is 169, minus 25, and you get 12. And it's positive. So that's step 1, is to draw all this stuff out. Okay, and then number 1 says find cosine of alpha plus beta. Okay, well, we know that this does not equal cosine of alpha plus cosine of beta. You do not distribute trig ratios. That's not it at all. We have a formula for cosine, so that's not it. It's on page 15, and cosine of alpha plus beta on page 15 is cosine of alpha cosine of beta minus sine of alpha sine of beta. So now I can look at anything that says alpha. I'm going to look at this triangle. So the cosine of alpha is adjacent over hypotenuse. So the cosine of alpha is negative 15 over 17. And the sine of alpha is opposite over hypotenuse. That's negative 8 over 17. And anything that has beta is going to use this triangle. So cosine of beta, this is beta, is adjacent over hypotenuse. So that's negative 5 over 13. And the sine of beta is opposite over hypotenuse. So that's 12 over 13. So it's really almost, it's like the problem we had to draw a right triangle in the test. It's just now we have to draw two right triangles because we have an alpha and a beta. So there's a minus right here. Okay, so these numbers are a little bit bigger than what you would have, but a negative 15 times a negative 5 is a positive 75 over whatever 17 times 13 is. I need a calculator for that. 17 times 13. That's 221 minus a negative, so I'm going to distribute that. That's a positive. And then 8 times 12, 96 over 17 times 13, 221. Add those because these are common denominator. So 75 plus 96 is 171 over 221. Okay, if anybody has another question, I think if you're still there, Dom, you have another 263 question, I think I can, everything's already ready to go, so hopefully it'll be quicker. Does that help, Paula? Okay, very good. I'm glad. Okay, well, the easiest thing to do is to tell you this rule here, okay? 1 over A over B is equal to B over A. That's just a rule. 1 over anything is just a way of saying it's the reciprocal of the denominator. So 1 over cosecant of x is 1 over sine of x, which is just sine of x. And that's true because we know that this means reciprocal whenever there's a 1 on top. 1 over cosecant of x is sine of x. The sine of x is the reciprocal of cosecant of x. Okay, so if you want to do the math, 1 over sine of x is equivalent to 1 times the reciprocal, which is sine of x. That's how you answered what? What is your question? I'm go back a little further. That's how you answered where. What are you referring to? Okay. Okay. Well, you see how you're leaving X off? That you might have not put the, this is important. So WebAssign may not have liked it. I'm not really sure. I'll have to look at that, and I can't really look at that now. But I can tell me what section of WebAssign it was and what number, and tell me who you are. Are you Yusuf? And I can look it up, but I really don't know what happened until I look at it. It may be a typo that you committed. Oh, right. Daniel. Okay. I couldn't remember Daniel. All right. So Daniel, WebAssign. Yes. WebAssign homework problem 2 or 3. Can you tell me what section, which quiz it was? Was it trig identities? Tell me, tell me, come back to me and tell me what section, and I can kind of try to look it up. Okay, Grania, could we go over a problem where we need to find the exact value of cosine 19 pi over 12? Would you use sum or difference? Yes. Yes, we would. Yeah, Daniel's going to give me the exact WebAssign because I don't know which one it is. And I don't remember. I'm looking at it, but let me see. So we have inverse trig, modeling with trig identities. It might be trig identities. I could check. So hopefully he'll get back to me on that. Okay. Okay. Yeah, sorry about that, Daniel. Okay. So you want to go over something like cosine of 19 pi over 12. All right. So I think I've helped somebody with this problem. So I know why this one's difficult because it's this 19 is bigger than the 12, but it's not quite more than one rotation. So you've got to kind of think of what numbers add up to be 19 that are also in the unit circle. And so you can do methodically. You can do 1 and 19, 2 and 18. 2/12 reduces to pi over 6, so that works. 18/12 reduces to, let's see, 3 pi over 2 right there. So you just got to cycle through all, that adds it to be 20. Never mind. Hold on. That was dumb. Let's try this again. So you have 1 plus 18, and that is 19, but that's 1/12, so that won't work. 2 plus 17, well, 17/12 isn't going to work. 3 plus 16, 3/12 is 1/4. 16/12 is 4 pi over 3. Still not on the unit circle, so let's keep trying. 4 plus 15 is 19. 4/12, that's on the unit circle. 15/12 reduces to 5 pi over 3. There it is. So 5 pi over 3 and pi over 3 are on the unit circle. Okay, so what I did was I took 19 and I just tried a couple, 1 and 18, 2 and 17, 3 and 16, and 4 and 15. Well, your 12 is going to reduce to a sixth, a fourth, or a third, because those are all the things that are on the unit circle, or half. Okay, so once I figure that out, the cosine of 19 pi over 12 is equivalent to the cosine of 4 pi over 12 plus 15 pi over 12. Okay, but that equals the cosine of pi over 3 plus 5 pi over, what did I do? Oh, I did it wrong. Divide by 3 and you get 5 pi over 4. Oops, right there. Okay, so that still works because that's on the unit circle. Okay, so then you use your sum formula. We know that this is A and this is B. And so if I'm looking at page 15 and I see the sum formula, cosine of A plus B is equal to cosine of A, cosine of B, minus sine of A times sine of B. So cosine of pi over 3 is 1/2, and cosine of 5 pi over, I keep wanting to put 3, but it's 5 pi over 4 is negative square root of 2 over 2, minus sine of pi over 3 is square root of 3 over 2, times sine of 5 pi over 4 is negative square root of 2 over 2. So that's negative square root of 2 over 4 minus a negative square root of 6 over 4, which is positive. And so then you get negative square root of 2 plus square root of 6 all over 4. Okay, so hopefully that helps. 1 and 18, 2 and 17, 3 and 16, 4 and 15, and keep trying them out until they reduce to some numbers that are on the unit circle. So they're all going to reduce to fourths, cubes, fourths, thirds, halves, or sixths. All right. Daniel, if there's no questions, I can kind of keep looking in the class view. Trig identities. Oh, it's wrong class. Okay, Unit 2, Trig Identity, Quiz 1, Question 2. Awesome. All right, let me look at it. Okay, scores. Johnson. Okay, I'm looking it up. I'll be with you in just a second. Okay, all right, let's do this. I'm going to write it on paper. Okay, so you have to use the fundamental identities to fully simplify this. Okay, that was your problem. That's number 2. And you have sine of t, but that's not what it reduces to. Okay? Oh, yeah, you had typed it out. All right. Okay, so this is cotangent here, which is cosine of t over sine of t. And tangent is sine of t over cosine of t over cosine of negative t, but cosine of negative t is an odd function. Okay, so I'm going to go ahead and change that to negative cosecant. I didn't mean to say cosine. Cosecant is an odd function, so I'm going to change that to negative cosecant of t. Okay, so up here, I have to get, this is one fraction. There's 2 fractions added together, so I need a common denominator. So I'm going to multiply this top one by cosine of t over cosine of t. And I'm going to multiply this one over here by sine of t over sine of t. And that's going to be cosine squared t plus sine squared t over cosine t sine t. Nope, the odd function, because this has sine in it, then this is an odd function. So cosecant of negative t is equivalent to negative cosecant of t. Okay, so what I had to do is get a common denominator and add those fractions together. So this is my numerator, and I'm dividing by negative 1 over sine of t. Okay, so now I can multiply this by the reciprocal of this, which is sine of t over negative 1, or negative sine of t. Okay, and this is 1. Cosine squared of t plus sine squared t, cosine squared t plus sine squared t is 1. So I have 1 divided by, and then these cancel. So I have 1 over negative cosine t. Well, 1 over negative 1 is the same thing as negative 1 over cosine of t. And 1 over cosine of t is secant. So that's your answer. Okay, got any other questions? Can I do number 2 on page 20? Okay, yes. So page 20. All right, it's the matching. Okay. So page 20, number 2, sine squared 3x minus cosine squared 3x. Okay, so what you have to do is go look at your identities on page 15, and you want to look for that either on the right-hand side or the left-hand side. Now that looks to me like this. Cosine of 2a is equal to cosine squared a minus sine squared a, because we have a sine squared a minus cosine squared a. So it's not quite right, but it's got squares and a minus. So it's the same thing as sorry about that. Same thing that I showed in one of the other ones we just did. So I'm going to write down the identity so we don't have to look back at page 15. Okay, so what we have to do is since we have the right setup, but this should be negative and that should be positive, what we can do is we can factor out a -1. So if we pull out the -1, we get negative sine squared 3x plus cosine squared 3x, which is -1 times cosine squared 3x minus sine squared 3x. So we just can't lose the -1, but now we have the right setup. We have cosine squared a minus sine squared a. So a is 3x, right? And so this right in here equals cosine of 2a. So we have the -1, and this in here equals cosine of 2a, which is 3x. So this ends up being -1 cosine of 6x. And so now we have to find it, page 20, which make sure that we got it right. We should be finding negative cosine 6x, and that's I. You're welcome. So that's 2 that we've done where you had to factor out a -1. So that's, like I said, the more you do, you kind of file that trick away. That if you almost have an identity, the only thing that's wrong is the signs are opposite of what they should be, you can factor out a -1. And for number 8, which formula could I use? On page 20? Well, honestly, that one's so easy. I think you got, that's just one that you have to have memorized. Unless we're looking at the different thing. Cosine of x over sine of x is cotangent of x. Simple as that. So you have to know that's what that's in there with the reciprocal identities. That's one that you have to have memorized. Sine of x over cosine of x is tangent of x. Yeah, you are everything. You're welcome. No problem. All right. Anything else you guys need? Okay. I'm glad that I could help. And don't forget, you guys have a Blackboard quiz due tomorrow by noon. And as soon as it's due, I'll post the key for it. One last question. Can you go over one of the questions for part 4, page 18? Sure. Okay, so part 4, verify the identity. Okay, so they're just identities, so you don't have a preference on which one I do? Okay, so I'll do 31. And I'm going to be needing to look at page 15. And so the first thing I notice is that this can be factored. The numerator of cosine, the fourth power of cosine x minus fourth power of sine of x, that factors into cosine squared x minus sine squared x times cosine squared x plus sine squared x. So you always want to, if you can factor it, and see if that leads you somewhere. And that actually does lead me somewhere, because this is a trig identity. Cosine squared x minus sine squared x is equal to cosine 2x. And then this is 1. So you just had to factor. Let's see if I try another one. Let's see, how about 32? Cotangent alpha minus tangent alpha over cotangent alpha plus tangent alpha is equal to cosine 2 alpha. Okay, so let's look at page 15. The left-hand side is more complicated, but I'm going to peek at the right-hand side and look at my 3 possibilities for cosine of 2 alpha and see if that helps me know what to do. And I really don't see what I need to do yet, so what I'm going to do is change all these cosines and tangents to cosine over sine and sine over cosine. But I also have, yeah, we'll try that. So this is cosine alpha over sine alpha minus sine alpha over cosine alpha over cosine alpha over sine alpha plus sine alpha cosine alpha. So I'm just trying to get one fraction. So if I multiply by cosine alpha over cosine alpha here, and sine alpha over sine alpha here, and this one by cosine alpha over cosine alpha, and this one by sine alpha over sine alpha, I get, right here, I get cosine squared alpha minus sine squared alpha over cosine alpha sine alpha. So I got one fraction in the numerator. And then down here I have cosine squared alpha plus sine squared alpha over cosine alpha sine alpha. Okay, so this is 1. And I have this fraction divided by this fraction, so I'm going to multiply by the reciprocal of this fraction, which is cosine alpha sine alpha over 1. And then cosine cancels with cosine, sine cancels with sine, and I'm left with cosine squared alpha minus sine squared alpha, and there's that trig identity, and that is equal to cosine of 2 alpha. Oh, you're quite welcome. Okay. Well, it's 9 o'clock. I think I'm going to log off now. Hope you guys have a good evening. And I'll see you tomorrow.